able to create the queries. So that's a workbench for SQL queries. This is the Oracle SQL queries workbench. So online also, this is like online compiler you can use in your mobiles also. Who doesn't have the laptops? Okay, please be practice, and I will share the answers also. Document I will share for employee department database. Okay, please practice and upload query and question query and the screenshot, output screenshot. Okay, has already created a folder in the Teams. All right. See, in the today's session, I'm going to discuss about deadlock. Are you able to view my screen or not? Yes, all of you. Today I'm going to discuss about the deadlock topic, and then how to prevent the deadlock. That means how to handle the deadlock. So that is called prevention. In that prevention we have wait die technique and wait wound technique. Okay, one transaction will going to be wait and other transaction going to die. So this will do vice versa. With wait die technique we will see. Okay, then wait wound technique we'll see. Then we will see the deadlock avoidance by using the technique called wait for graph. Okay, so first we will see what is deadlock. So in operating system you already learned, I think, this one. This is explained in the operating system very well. So now we will see regarding to our database management system. Okay, getting my voice. What is deadlock? Already you have seen in your operating system subject. What is deadlock? Tell me what is deadlock. Can someone reply? What is deadlock? How you can define a deadlock? Let's tell me, all of you.
All the resources will be, all the process will be waiting for resources.
Yes, that's what simple way. All the resources are waiting for, so all the transactions are waiting for resources. See, how to find this simple way. It is a situation or more waiting for one another. Loss. So you can define deadlock. It is a situation in which two or more transactions are waiting for one another to give up the locks. To give up the locks. See, for example, I have transaction T1. I have a transaction T1 and the transaction T2. So it is holding X, transaction 1 holding X and waiting for Y, and T2 holding Y and waiting for X. See here, ma, we have two transactions. First one T1 transaction and T2 transaction. T1 having X data item, and T2 having Y data item. See, to complete one transaction, T1 needs Y data item and T2 need X data item. See, for this, T1 is waiting for Y and T2 is waiting for X data item. That means what? T1 is waiting for T1 transaction is waiting for T2 transaction, and T2 transaction is waiting for T1 transaction. So if the T1 transaction having these two, then only it is going to complete one transaction successfully. Otherwise, it is incomplete. So here T1 transaction is waiting for T2 transaction item Y, and the T2 transaction is waiting for T1, that is X, for data item X. So it is called as deadlock state. This is called deadlock state. Okay, if T1 releases X, then only T2 transaction going to complete. If T2 transaction releases lock on Y, then only T1 transaction going to complete. Okay, so now it is not releasing, so both are in waiting state. That means at least one transaction is not completing here. That means these two are in deadlock state. This is what we can call as deadlock state. Okay, yes, all of you. See, for example, we have two processes now, P1 and P2. Okay, P1 and P2 processes I have. So P1 is waiting for R1 resource, P2 is waiting for R2 resource. P1 assigned to R1 is assigned to R1, and P1 waiting for R2 resource, wait for R2 resource. R2 is assigned to P2 resource. P2 is waiting for R1 resource. P2 is waiting for R1 resource. That means both are in waiting state. So there is no chance to get a successful transaction. So that is called deadlock state. Okay, have you understanding? Did you understand? This all of you, deadlock state. Okay. Coming to our database management system, how we can see these transactions here. We have T1 transaction and T2 transaction. T1, T2. We have two transactions here. Okay. See, you know exclusive lock and shared lock, right? Exclusive lock. Exclusive lock on X data item. And shared lock on data item X. See, exclusive lock means what? So by using exclusive lock, we can perform read operation as well as write operation. We can perform read or write operation. By using shared lock, only we can perform read operation. Only we can perform read operation. As you know already, exclusive lock and shared lock. See here, the example I'm going to explain here clearly how deadlock is happening with this transaction, T1 and T2 transactions. So lock on X data item, that is exclusive lock. Lock on X data item. Okay. Next, I am performing read operation on X data item, and then I can perform write operation on X data item in T1 transaction. Okay. Here, performing exclusive lock on Y data item, and then I'm performing reading operation on Y data item. Then I'm performing write operation on Y data item. Okay. After that, see here, observe here clearly. I'm performing exclusive lock on Y data item. That means I'm performing reading and writing operation, and I'm performing read operation on Y data item and write operation on Y data item. Then here in T2 transaction, I'm performing lock, that is exclusive lock on X data item, then performing read operation on X and write operation on X data item. See here, I am reading X value and writing X value. I performed the exclusive lock on X data item. I performed the exclusive lock here. And here in the T2 transaction, I performed exclusive lock on Y data item. Here I'm trying to see here lock on Y data item. So I'm trying to write Y value here from this T2 transaction. So already the Y data item is in lock condition, right? Then how can I write here? How can I read and how can I write here? So that means this T1 transaction is waiting for T2 transaction. For what? To release lock on Y data item. See, are you understanding? Did you understand this? So already for Y data item we have lock on T2 transaction. In T2 transaction we have lock on Y data item. Then how can I access that Y data item in T1 transaction? In T1 transaction, how can I access? So that means what? So till it completes the lock, then till it releases the lock, here it is in waiting state. It should be in waiting state. So T1 is waiting for T2 to release lock on by data item. Are you understanding? Same like, see here, in T1 transaction, we have lock on, exclusive lock on X data item. Okay. In T2 transaction, I am trying to read and write that X data item. Is it possible? No, because it does till now it doesn't release any lock. So that means here this T2 is waiting for T1 transaction to release lock on X data item. Are you understanding? So we have two transactions, T1 and T2 transaction. I'm performing lock on X data item in T1 transaction, and I'm performing lock on Y data item in T2 transaction. Then here the T2 transaction trying to access X data item. Okay. So this is called deadlock state, and the T1 also waiting for T2 transaction to release the lock. So these two situations here, one is waiting for another, so that means called it is in deadlock state. Okay. So here by using transaction example I explained. So deadlock states, how it is occurring. Okay. So that's what about deadlock. Sir, now how I can prevent the deadlock, or how we can avoid the deadlock. See how to handle these deadlocks. See what is deadlock here? What is deadlock? What is the deadlock? See, consider two transactions, T1 and T2. Consider two transactions, T1 and T2. If T1 holds lock on data item X, then T2 holds lock on data item Y. Now T1 prefers lock over Y and T2 requests lock over X. Then it is in lock state. So now, sir, how to handle the deadlocks? How to what is the prevention? So this is the answer here. We have two techniques: wait die technique and wait wound technique. By using this, we can handle the deadlock. First technique is what? Wait die technique. First technique is what? Wait die technique. So in wait die technique, the older transaction waited in queue. The older transaction is waited in queue, and the anger will be die. Anger will die. So coming to wait wound transaction. So here older transaction waited state, right? Here younger transaction will be in waiting state and the older transaction will going to get die. Okay, see I'm comparing here. Okay, the next point, see the first point, in wait to die technique, the older transaction waited in queue and younger will die. The older transaction waits for younger if the younger has access the granule first. Okay, the younger transaction is aborted, means it is going to die, and restarted, it tries to access granule after older concurrent transaction. The wait based on timestamp of the transaction request for the conflict resources. Request for resources. See, I can explain here. The transaction, that the timestamp, these all are based on the timestamp. We can see wait die based on the timestamp of the transaction, a request for the conflict resources. Request for the conflict resources. First one, the timestamp of T1 transaction. T1 transaction. The timestamp of T1 transaction. The timestamp of T1 transaction is less than the timestamp of T2 transaction. So we'll wait in a queue and see here. This is the first condition. So the timestamp of T1 is less than the timestamp of T2. Here T1 will wait in the queue. So T1 is in the waiting state. So we'll wait in the queue and what about T2? T2 will be die. T2 will die. Die or abort. Second point is what? The timestamp of T1 transaction is greater than the timestamp of T2 transaction. Then T2 will be in waiting queue. T2 will be in waiting queue and T1 will die. So that is called wait to die technique. It is done by using the timestamps. So the timestamp of T1 is less than the timestamp of T2. Then the T1 transaction wait and the T2 transaction is going to be die or abort. Second condition, the timestamp of T1 is less than the timestamp of T2, then T2 will wait and T1 is going to die. For example, for example, I have transaction T22, T23 and T24. listen clearly. I have the transactions. Suppose that the transactions are T2, T20, 5, 10, and 15. Here, younger transaction is what? Latest transaction, T24. Okay. So suppose the transactions are T22, T23, T24 have timestamps 5, 10, and 15 respectively. If T22 request data item held by T23. Here I have the X data item in T23. So if T22 is requesting a data item held by T23, okay, then T22 will be in waiting state. So it is in, so that means the based on these conditions, explain two conditions, right? T1 is greater than T2. For T1 22 is waiting, okay, and if the transaction T24 request T24 remember. Yes, Alafi, are you getting my screen? Can you hear me? F7.
Yes, sir. Yes, sir. I can
F7,
hear
are
you.
you getting my voice?
Yes, sir, but it's struggling, sir, in somewhat middle.
Okay, just now it's structured. That's why. Okay. See, based on this condition, if timestamp of T1 is less than timestamp of T2, then T1 is waiting state and T2 will going to die. And second condition, the timestamp of T1 is greater than the timestamp of T2, then T2 is waiting state and T1 will going to die. So that's what I am explaining here. We suppose we have transactions T22, T23, and T24, and the timestamps are 5, 10, and 15 respectively. Then the T1 transaction is requesting for data item held by T23 transaction, then this T22 is in waiting state. Okay. If the T24 is requesting data item held by T23, okay, now then the T24 will be in rollback. Okay, based on this diagram, you can write the example, you can write the theory. What we can write here? Suppose we have a transaction T22, T23, and T24, and the timestamps have is timestamps 5, 10, 15 respectively. If the T2 transaction a data item held by T23, then T22 is in waiting state, and T24 is requesting data item held by T23, then the T24 will be, we can do rollback. Okay, so that's about what wait to die technique. That's about wait to die technique. The second technique for deadlock handling, wait to wound technique. Wait wound technique. Wait wound technique. What is this technique? So it is based on the timestamp of transaction request. It is a preemptive technique, deadlock prevention, and it is a counterpart scheme. When the transaction Ti is request data item currently held by Tj, and Ti is allowed to wait only if it has a timestamp larger than Tj. Otherwise, the Tj rollback. The Tj is rollback. That is, Tj is owned by Ti. So the Tj is rollback. That means the Tj is owned by Ti. Trying to understand this theory. It is a preemptive technique for deadlock prevention. It is a counterpart to the wait die scheme. And when the transaction Ti requests data item currently held by Tj, and Ti is allowed to wait only if it has a timestamp larger than that of Tj. Otherwise, the Tj is rollback. The Tj is rollback. See, for example, this is called wait to do technique. Wait to do technique. Wait to do technique. Okay. So see the example. We have the transactions. We have the transactions T22, T23, and the T24. Okay. And the timestamps are what? 5, 10, and 15. Here, if transaction 22 T22 request data item held by 23, we have data item in transaction 23. Here T22 is requesting for data item, held by T23. Then the data item will be preempted from T23, and T23 will be rollback. T23 will be rollback. T23 will be so now it is in, we can do rollback T23. If T24, this transaction T24 requesting data item held by then T24 will be in waiting state. T24 will be in waiting state. See, I think you understand here. So we have wound, wound technique. So what is the technique here? Suppose we have the transactions T22, T23 and T24 and the timestamps are 5, 10 and 15. The younger one is T24 here and the older one is T22, right? And if the transaction T22 is requesting a data item held by T23, and then the data item will be preempted for from T23 and the T23 will be in rollback. If the transaction T24 requesting data item held by T23 and then the T24 will be in waiting state. So here then the younger transactions are made to wait. Here the younger transactions are made to wait in a queue and the older transactions going to aborted. The older transactions going to aborted. Okay, the older transactions going to aborted. Okay, see the conditions here. Based on condition, I'm going to explain here. Conditions. First condition. See, the timestamp of T1 is less than the timestamp of T2. Okay. Then here T2 will waiting state. T2 will in waiting state and T1 aborted. T1 aborted. The second condition, the timestamp of T1 is greater than the timestamp of T2, then T1 will in waiting state. T1 is waiting state and T2 aborted. T2 aborted. These are the two conditions in wait wound technique. Wait wound technique. I think you understand, right? So you have only theory in the document. So please try to draw the diagrams. Then you can understand easily and you can write the theory easily. Okay. Yes, all of you. Okay, now the time is up. So we have seen only two techniques here. We have seen only two techniques. Those are called wait die technique and wait wound technique. Okay. In the tomorrow session, I'm going to explain deadlock avoidance by using wait for drop technique. Okay. Today we have seen the two techniques here. So how to handle the deadlocks here means by using wait die technique and wait wound technique. Okay. How to avoid deadlock means by using technique called wait per graph technique. I will explain this wait graph technique in tomorrow class.